protein requirement to feed the estimated population of 1400 million by 2025 will be 300 million tons. So, the further increase in crop production will have to come only from increasing in yields, since there is no possibility for increasing cultivated area. We all know that agricultural growth is mainly dependent on advances in farming technologies. If the yields of our major crops are relatively low, then there will be great possibility for increasing them through the increased use of inputs such as fertilizers. So, in this episode, we are going to study some interesting aspects of fertilizers under the following headings, that is, fertilizers, characteristics of fertilizers, techniques of fertilizer application, fertilizer efficiency, disadvantages of fertilizers. The term fertilizer means any organic or inorganic material containing one or more of the recognized plant nutrients, which is used primarily for its plant nutrient content. These materials are designated for use or claim to have value in promoting plant growth and increasing plant available nutrient levels in soils. The fertilizer contain the three basic nutrients for agriculture, that is nitrogen, phosphorus and potassium. Nitrogen is primarily provided by nitrogenous fertilizers such as urea, which contains 46% of nitrogen, or ammonia fertilizers, example ammonium sulfate, which contains 20.6% of nitrogen. Further shades of nitrogen are contained in complex fertilizers that combine all three plant nutrients, that is N, P and K. Coming to types of fertilizers. In general, there are two types of fertilizers, namely organic fertilizers and inorganic fertilizers. Inorganic fertilizers are usually synthetic and chemical based. They primarily consist of nitrogen, phosphorus and potassium, which are non-biodegradable in nature, whereas organic fertilizers are of biotic origin, consists of naturally decaying materials like sewage waste, crop residues, green manure, etc. There are some important facts to know about fertilizers. They are the trends and changes in fertilizer use, some conditions when fertilizer use will not be profitable, plants differ greatly in nutrient needs and in the amounts of added fertilizers needed, the fertilizer grade and the exact meaning of each number, the important characteristics of fertilizers such as their salt effect, present and potential acidity, solubility and mobility in soil, factors that affect fertilizer efficiency, the calculation of elemental contents and the fertilizer grade, calculation of weights of nutrient carriers to prepare fertilizer mixers and so on. Fertilizers are soluble salts. Some are saltier than others. Some fertilizers are acid forming or initially basic. Not all fertilizers are easily soluble. Some nutrients are mobile than others in soil and not all are suitable for liquid fertilizers. All of these properties modify how and what we buy for use as fertilizer. Fertilizers as soluble salts. Soluble salts are all soluble ions. Thus, most soluble fertilizers are soluble salts. Because of strong adsorption precipitation of some ions like phosphates and calcium and absorption or loss of others like nitrate, some materials cause greater short time and long time effects than others. Phosphates are usually low salts. Chlorides, sulfates and nitrates are high in their immediate salt effects. Acidity and basicity. Most fertilizers are used on acidic soils, so the possibility that fertilizers might aggravate soil acidity is of great concern. Next, solubility and nutrient mobility. Most phosphates are of low solubility and can quickly form insoluble calcium, aluminum or iron salts in mixtures. Mostly ammonium phosphates and phosphoric acids are used to supply phosphorus in liquid fertilizers. Solid and liquid fertilizers. A limited amount of study has been made comparing reactions of liquid and solid fertilizers. The liquid fertilizers will often spread more, running through large cracks and contacting more soil than do pellets of dry fertilizers. When applied at the surface, liquid fertilizers may partly move into the soil. When crop yield differences have been observed, usually the liquid fertilizers has produced higher yields than the solid materials. However, equipment cost and handling techniques are different between liquid and solid fertilizers. So, serious evaluation of the benefits should be made before making changes in the kind of fertilizer used. Next, complete versus incomplete fertilizer. A fertilizer is said to be a complete or mixed fertilizer when it contains nitrogen, phosphorus and potassium, that is the three primary nutrients. An incomplete fertilizer will be missing one or more of the major components. Examples of incomplete fertilizers are ammonium nitrate, urea, diammonium phosphate, triple superphosphate, muriate of potash, etc. Next, fertilizer ratio. The fertilizer ratio indicates the proportion of nitrogen, phosphorus and potassium contained in the fertilizer. The specific fertilizer ratio you will need depends on the soil nutrient level. For example, a 1:1:1 ratio is widely used at planting time when both phosphorus and potassium are in short supply. When soil test high or very high in phosphorus and potassium, a 1:0:0 ratio may be a more appropriate choice for use at or near planting. There are various ways to add fertilizers. Some of them are starter or pop-up. Fertilizer is added with or near the seed, that is within 0 to 5 centimeter distance for immediate use by the young seedlings. Next is the broadcast method. In this method, fertilizer is uniformly spread on the soil surface. It may or may not be incorporated into the soil. Next is the deep banding. Here, fertilizer is placed in a strip at a depth of 14 to 18 centimeter. Usually the strips are 30 to 70 centimeter apart, placed at planting or in pre-plant without regard to rows. Next is the split application. In this method, the fertilizer is added in 2 or more portions at different times during the season. Next is the side dressing or strip placement and top dressing. Here, often these terms are used to mean fertilizer added after the crop is growing. Side dressing can involve insertion of fertilizer into the soil beside the growing crop. Strip placement and top dressing may be placed as strip on the soil surface near plants rather than being broadcast over the entire soil surface. Plant injection. A narrow cylindrical tube called injector penetrates the soil and allows fertilizer to be inserted at the depth of penetration. Usually liquid fertilizer is used in this technique. The injectors may be on wheels like rolling point injectors at any frequency and the required spacing. This technique allows fertilizers to be inserted into the soil with minimal damage to the roots. Next is the fertigation. Fertigation is the application of fertilizers in water as in irrigation water. Next, foliar sprays. This is the application of liquid fertilizer to the foliage of plants just enough to wet the leaves. Coming to fertilizer label. The fertilizer guaranteed analysis or grade stated on the back refers to how much of an element is in the material based on the percentage by weight. Goals and concerns in using fertilizers. Crop producers have several goals in using fertilizers: to increase yields, to reduce cost per unit of production, to increase plant quality and to reduce certain diseases. The first two goals are of most common reason for adding fertilizers. Efficient land managers spend perhaps 20% of all production cost on chemical fertilizers and expect increase in yield of up to 50%. Fertilization is not profitable when first one, water is the limiting factor, second, other growth barriers such as insects, diseases, strongly acidic soils, saline soils or cold temperatures regulate growth, and third one is the increased yield has less market value than the cost of buying and applying fertilizers. Fertilizing crops usually has its major purpose to produce better and larger yields, often at decreasing cost per unit of production. To accomplish these goals, it is essential to know how much of the critical nutrients the crop will need. Fertilizer efficiency is defined as the percentage of added fertilizer that is actually used by the plants. It is assumed excess nutrients are not absorbed and that all absorbed nutrients was necessary for increased yields. But these assumptions are not always true. In general fertilizer usage, the expected efficiency are approximately 30 to 70% of added nitrogen, 5 to 30% of added phosphorus and 50 to 80% of added potassium. These values can be improved by using special care. The values can also be even lower because of bad weather or carelessness. Looking at the fertility problem from the grower's view, The addition of any amount of fertilizer is of interest only if it profitably enhances yields, either larger yields or better quality yields. The benefits from fertilizer additions must exceed the cost of purchasing and applying it. Sometimes even the inconvenience or time needed at a busy period can be major concerns in evaluating the proposed fertilization. A number of factors affect fertilizer efficiency and crop responses to added fertilizer. The plant itself will vary because of the nutrient it needed and its kind of root system. Water availability, temperatures, pests like weeds, insects and other organisms and management are all important. The effectiveness of fertilizers can only be assured if applied in optimal combinations specific to the local soil and climatic conditions. Coming to fertilizer production and consumption in India. Fertilizer production has increased from less than 1000 tons of total nutrients from 1970s to almost 17,000 tons today, and consumption has increased from 2000 tons to almost 27,000 tons. The introduction of high yielding varieties in the 1960s boosted fertilizer use. The high grain and fertilizer prices on the international markets during the oil crisis of 1973 to 1974 provided a further impetus to policies aimed at improving the country's fertilizer supplies and food security. The production of nitrogen and phosphate increased from 830,000 tons and 229,000 tons in 1970 to 71 to 11,900,000 tons and 4,321,000 tons respectively in 2009 and 2010. In the absence of domestic natural resources, all potash fertilizers are imported. The imports in 2009 and 2010 were 3,000 tons compared with less than 1,000 tons in the 1970s. The intensity of fertilizer consumption varies greatly from 2,177,000 tons to almost 26,486,000 tons. The intensive use of chemical fertilizers has side effects in polluting underground water, destroying microorganisms and insects, making plants more susceptible to the attack of diseases and reducing soil fertility. Therefore, the development of satisfactory alternatives for supplying the nutrients needed by crops, the so-called green agriculture, could decrease the problems associated with conventional NPK chemical fertilizers and thereby protect both the environment and human health. Environmental degradation is a major threat tackling the world, and the rampant use of chemical fertilizers contributes largely to the deterioration of the environment through depletion of fossil fuels, generation of carbon dioxide and contamination of water resources. It leads to loss of soil fertility due to imbalanced use of fertilizers that has adversely impacted agriculture productivity and causes soil degradation. Despite the unprecedented role of synthetic nitrogen fertilizers have played in increasing agricultural crops and livestock production and meeting the nutritional requirements of a growing human population, strong evidence has emerged demonstrating the detrimental effects of the increasing amounts of reactive nitrogen in the environment. Among the deleterious effects of excessive environmental nitrogen are acidification of soils and water resources, eutrophication of coastal marine ecosystem, loss of biodiversity in terrestrial and aquatic ecosystem, and invasion of nitrogen loving weeds, increased greenhouse gas levels due to emission of N2O, depletion of stratospheric ozone, increased ozone induced injury to crops, forest and other ecosystem, and increased atmospheric haze and production of airborne particulate matter. Biofertilizers. The use of biofertilizers is of relatively recent origin. Biofertilizers consist of nitrogen fixers like rhizobium, azotobacter, blue-green algae, azolla, phosphate solubilizing bacteria and fungi called mycorrhiza. A contribution of 20 to 30 kg nitrogen per hectare has been reported from the use of biofertilizers. There was good growth in biofertilizer production and use in 1990s. At present, biofertilizer use is about 10,000 tons. Among biofertilizers, most growth has occurred with phosphate solubilizing microorganisms, which account for about 45% of total biofertilizers production and use. Biofertilizer production and use is concentrated in Maharashtra, Tamil Nadu, Karnataka, Madhya Pradesh and Gujarat. Coming to the significance of fertilizers. Adverse effects of modern agriculture practices not only on the farm but also on the health of all living things and thus on the environment have been well documented all over the world. Application of technology, particularly in terms of the use of chemical fertilizers and pesticides all around us, has persuaded people to think aloud. The negative effects on the environment are manifested through soil erosion, water shortages, salination, soil contamination, genetic erosion, etc.